we are going to start talking about Unit 1. Did anybody actually take a look at what Unit 1 is? Well, we looked at it on day 1, so shouldn't be too out of the ordinary here. Here's Unit 1. 4 ways to represent a function: verbally, numerically, graphically, algebraically. Domain and range of a function, piecewise defined function, symmetry, increasing, decreasing. Using your fingers here, show me 5 is you totally understand all of those. 4 is they're pretty familiar. 3 is they're vaguely familiar. 2 is I think I understand the words. And 1 is I've never seen any of those words before. So where do you stand? Where do you stand here? 5-ish, 4s, 3s, 4s. Pretty good. You've seen some of this stuff before? We're pretty good. We've seen some of this stuff before. This is what I'd like you to do. You're going to take 5 minutes by yourself, and you're going to write down at least 2 things you know about each section. So you should write down at least 10 things. If you don't know anything about one of these, you could write down I don't know. So you can do that by yourself right now. We're gonna make a big list of everything that this class knows about these topics. Something specific, a couple things specific for each one. 1.1. Let's see here. Grace, can you tell me one thing about the first topic? One thing? Anything? Okay, that's fine. Bjorn, what's one thing?
Graphically.
That's a noun, yes.
Right. To express a function graphically, put it on a graph.
Okay, without using the word graph, can you explain what graphically means?
In 2 dimensions with...
What are you drawing? You're drawing a...
shape, a line.
A picture, there you go, of a function. It doesn't have to be a line, does it? Yep, but yeah, you're visually representing it. Autumn, can you give me something about 1.1? Something specific.
Algebraically, like the equation.
Yep.
The function.
So algebraically means a function representation. How? Such as. Yeah, there you go. So here's a line: y equals mx plus b. What is that called? What is that called? Anybody can answer that. That's a linear equation, but what type of linear equation? Slope intercept form. Slope intercept form. Can someone give me another type of equation of a line? Another type? Y minus. Y minus y1. Yeah. What's this called? Pang, do you know what this is called? To the left. Point slope form. Yeah. So those are some general forms of lines. Yeah, that's nice. What's something else you can tell me about functions? Yeah. For every one input, there is one output. I like that. What else? I'll ask you this question. Well, before I start asking you more questions, you guys can tell me something. How about Corey Powers? Can you tell me something about 1.1? Anything else? In what way? How are they organized? When you numerically represent a function, those numbers are generally written in a table. Table of values, sure. Let's go with Alan. Do you have something else about functions? Yeah, verbally. What does that mean? Yep. Explain with words. So that's not saying out loud. X squared plus 9, that's saying it's a parabola with a y-intercept of 9. The parabola is facing up. There is symmetry. It's verbally explaining what that function is. It's not just verbally explaining what the numbers are. Like a verbal representation of 125 is me saying 125, that's true, but I could also say it's 5 to the third, it's 5 times 5 times 5, it's less than 126 but greater than 124. Give it a little bit more detail. Does anybody else want to add anything in? Anything else about 1.1? Anything else you've studied in function land? Standard form. Ah, there we go. I love standard form. What is standard form? Yep. Sometimes you see the C on the other side, but it's AX plus BY. Generally speaking, A, B, and C are all what? They're all integers. They could be negative, yeah. They're all integers. So if they're fractions, you multiply by the common denominator to make them not fractions anymore. That's generally speaking what you're looking for. And in general, A is usually greater than A is greater than 0. If A is less than 0, you multiply everything by -1. Leading coefficients being positive are generally more common.
So it's okay if the C is on the other side?
Yeah, it is. Sometimes you see it on the other side. I kind of like it all on one side, mainly because how many times have you put everything on one side and made it equal to 0? You do that a lot, right, to solve equations? Because then you can factor it. So it's kind of a good practice to be in. But they all represent the same function. So could you write the function many ways? I think I just asked you about that on a quick quiz this morning. Yeah. Anything else about 1.1?
For every output, you can have at least one input.
That's a good way to say that. I like that. For every output, you must have at least one input. What does that mean? More than one input can go to the same output. Absolutely. A picture would be here's an output right here. Y equals 2. How many different x values have y equals 2 when you plug the x value into the function? At least 9 right there, it looks like. At least this many? At least 9 of them. Can you flip it like this? Would it still be a function? Is this a function? No. What does it not pass? Yes. Functions must pass the vertical line test. Exactly. Can someone tell me what the vertical line test is? Or actually, you know what? Let's just figure this out first. Before we even do that, you need to answer this question for me. Now I can ask you questions. What is a function? What is it? You've studied these at length in other classes. What's a function? Jessica Brown. What's a function? Doesn't have to be complete. Just give me something about what's a function. What does a function do? Goss. A function is a rule that takes elements from one set and puts them in another set. The big kid way of saying that it's right there. Oh, well, I'll get rid of that and press the right button. I can read that out loud. A function is a rule that assigns to each element x in a set A exactly one element called f of x in a set B. So, all functions are relations. It's a relation between two sets. But all relations are not functions. For example, have you ever seen something like this before? Circle with radius 1. Is that a function? No. Is that a relation? Yes. What is the relationship? X squared plus y squared is 1. This is a relationship between what? X and y. A relationship between x and y. Exactly. Okay. Do you always have an equation? No. I mean, I could give you something like this. And I could say, is that a function? And you would say, no. All you need is one vertical line that passes through more than one point. So we haven't written it out yet. Now that we know what a function is, the vertical line test, can someone say it out loud to me? The whole thing? There's many different ways to say it.
You put like one line down, or like
Uh-huh.
one line shape. If it passes line between
Points.
then it's not.
Let's say it like this. A relation is a function if what? If no vertical line. Keep going. That passes through more than one point on the graph. That's what you're talking about, right? Cool. Okay, so let's move on now to 1.2. It was domain and range, right? I think. Carolyn Lawler, can you tell me anything about domain or range? Domain of a function. Now, it's all the possible x values. So you could say, I'll write that down, all the possible x values. What's another way to say that? Yeah, instead of x values, the set of all input values. Exactly. Now, what about range? Ah, there we go. Yeah, the set of all output values. Exactly. Generally speaking, which one is harder to find, do you think? Domain or range? Which one do you think is generally harder? Yeah, generally. Let's say I gave you a function that looks like this. And I'll label a few of these points. A, B, C, D, E, F, G, H. Can someone tell me what the domain of this function is? Anybody. Can anybody tell me the domain of this function? Raise your hand and I'll call on you. What's the domain? Grace. A to G. So you could say A to G. That would be the interval notation right there. You can also say x is between or equal to A to G. That's correct. A all the way to G. Can someone tell me what it looks like the range is? Raise your hand. What do you think the range is, Lawler? F to what? Yeah. F to D. Absolutely. Good. Why F? Why is F all the way on the left? Why'd you choose F? Lower than what? What's it lower than? What? It's the lowest of all the points, exactly. So why'd you choose D? Couldn't there be multiple highest points? Sure, but the y value is going to stay the same, right? Absolutely. So domain and range. Generally speaking, if you don't have a function, if you don't have a graph, sometimes it can be challenging. Now, let's say I gave you a function. Let's just say I gave you the equation of a function and it looked like this. Something similar, right? Let's say I didn't label the points, but I gave you the function, y equals f of x. How do you, at this point in your math career, what's the only way for you to find those 2 points? We'll call them A and B. They're vertices. They're called vertices, but do you know how to do that algebraically? No. When you take AP Calculus, you will learn how to find those points algebraically. Right now, though, what do you guys have to use to find those points? What? Yeah, you're going to have to use this. You're going to have to use this. So, for example, let's find some lowest points here. I don't think it'll control it. Let's try it. How about y equals... How about x minus 3, x and, what do we want the other 0 to be? X, I don't know, plus 5. Let's zoom standard. Let's zoom out. You ever use zoom fit? What number is fit? Do you remember? 0? Yeah. Zoom fit, it picks what it thinks is a good window. But it makes it look a little too flat, right? So what should I do now to get what I want to look at? Zoom what? Has anybody ever used zoom box before? If you use zoom box, you actually specify where you want the window to be. So you specify the top left. And then you specify the bottom. Bottom what? I can't hear. Bottom right. It's going to take me a second here. It's a bigger window. But if I click all the way over, and then I hit enter, and go way too far, there we go, whatever. Maybe you're interested in finding the upper and lower points, though. They're called relative minimums and maximums. How many people have done this on their calculator before? Have you graphed something on your calculator before? Yes. Yeah. Could you graph something curvy like this? Use the zoom functions. If you go second trace, so hit the calc button, which one do I want? Let's do maximum. It asks you for the left bound. So let's go, the maximum is over here. We're going to go to the left of that maximum. You press enter, and then you go to the right of the maximum, and you press enter, and then it asks you for a guess, and you press enter. Look at that. We now have is it kind of neat that it came out to a nice number like that? Is that completely random? Yeah, you're not always guaranteed to have a nice number like that. But the maximum of this function is negative 336. The relative, in that neighborhood. Now, if we wanted to find this other point right down here, you would do the exact same thing, but what would you choose instead of maximum? You would choose minimum. So for now, if we want to find those points, you will use your calculator. Sound fun? Okay, so now I have a present for you. Let's go to Pang. What did you get for number 1?
0.
F of negative 1? Who thinks it's 0? Oh, no friends today. Let's go with Ethan Goss. Who thinks it's negative 2? It is negative 2. You want this point right here. That point right there is, when x is negative 1, what's y? Negative 2. Absolutely. What about B here? Let's go with Jonathan. What do you think f of 2 was? F of 2.
It's around 1.7.
Yeah, you need that point right there. So it's 2 comma what?
1.7.
Not, oh, it's 1 here, 2 point. 2 points, around 2.7? Around 2.7? For what values of x is f of x equal to 2? Let's go with Sophie. That's one of them, yep. So here's 2, right? Where does the function value equal to? Well, it equals it at 1 and where else? Negative 3. So x is equal to 1 and negative 3. Estimate the values of x such that f of x is 0. When f of x is 0, what types of points are you finding? What are they called? The x-intercepts, the zeros. Eliza Salmon, what are your estimates?
I was thinking about
0.3, and where else though? There's another one.
At
Negative 2. Yeah, negative 2.5. State the domain in range. Who can tell me what's the domain of this function? Let's go with Claire. What do you think the domain is?
I had -3 is less than or equal to x, which is greater or less than equal to 3.
Yeah, so you can write it like this, or like that, or like, leave it like that. That's fine. So this is the interval notation. Okay, what about so this is the domain. Can anybody tell me the range? I'll have a volunteer for the range. Anybody tell me the range? Yeah. Yep. Yep. You would say y is less than or equal to 3 and greater than or equal to -2. Excellent. So what about, that was E actually, not D. So what about F here? It says, on which interval is it increasing? Who can answer that one for me? Where is it increasing? Eliza.
I said from -1.
From -1 to what?
-2 to 3.
To 3. And where is it decreasing? Someone else? -3 to -1. Now you'll notice I didn't put hard brackets. Is the function increasing or decreasing at -1 and at -3 and at 2? At 3? At these 3 points, here, here, and here, is it increasing or decreasing? What do you think? Well, let's call this point A, let's call that point B and point C. At point B, is it increasing or decreasing at point B? Neither. And at the end points, it's also considered to be neither increasing or decreasing for our intents and purposes. So, you notice how I didn't put that right there, or this? It's not increasing at -1, it's neither. At x equals -1, the function is neither increasing or decreasing. In AP Calculus and in Calculus, you study that for a very long time. Finding places where it doesn't increase or decrease. Those are very important points. Maximization problems, minimization problems. Your homework for tonight is in this packet. It'll be, I'll copy it in there, it'll be these questions in the packet right here. This will be in your notes right now. Have a good rest of the day, everybody.